So hi, good day folks. I'm Dr. Harish and today I'll be taking you through a process of solving Rubik's Cube starting from the 2 cross 2 to 3 cross 3 to 4 cross 4 to 5 cross 5 to 7 cross 7 and then on the simulator, on the GabaSoft simulator on Windows and IsoSim we can use on Mac. I'll be taking you to the 20 cross 20. So, and with that extension, you'll be able to solve any cube starting from 2 cross 2 to 50 by 50 or any big cube. So these are the things I want you to mug up. This is Ruri, Ururi, Rifri, Bir, Firi, Bir, Ui, Full, Rifli, Rough. Then these two are for solving 2 cross 2 cubes, and this is for solving a 3 cross 3. 1 2 3 2 prime 1 2 3 prime, that is for solving 4 by 4 or 5 by 5, and that is for solving the last two centers by swapping. This is a parity algorithm, LL prime U2 LL prime U2 F2 LL prime F2 R U2 RR prime U2 LL2. So these four algorithms I want you to mug up, these 5 algorithms. And then to solve a 4 cross 4 or even centered cubes, we need to mug up the following things we need to mug up this, we need to mug up this. I'll show you the demo of these. It's going to be a long video, folks. And these are the algorithms. So this one, that's not the algorithm I wanted to mug up. This is the 4 cross 4 printout. You can take it out from the website. This is the edge parity algorithm, one. And then these are the 2 edge parity algorithms in the final layer of the solve. So now let us go through these Rubik's Cubes and then solve any Rubik's Cube. It's going to be an easy task once you go through all the algorithms and once you solve all the Rubik's Cube repeatedly. One key to note is that for a beginner, it takes about 1.5 minutes to solve the 2 cross 2, 3.5 minutes to solve the 3 cross 3, around 20 minutes to solve the 4 cross 4. So if you solve the 2 cross 2 twice, you'll be able to solve the 3 cross 3. If you solve the 3 cross 3 about 10 times, you can solve the 4 cross 4. If you solve the 4 cross 4 twice, you can solve the 5 cross 5. If you solve the 5 cross 5, so it takes about 4 hours to solve the 7 cross 7, 4 hours 30 minutes to solve the 7 cross 7. So if you solve the 5 cross 5, which takes 30 minutes, if you solve it 9 times, you can solve the 7 cross 7 and so on. That way you can calculate, so you can practice on a smaller cube many times and then you'll get the mental resolve to solve the bigger cubes. So that's the introduction to the Rubik's Cubes, and let's move on in this. Okay, hi. So I'm Harish. So let us first solve the 2 cross 2. Maybe a close-up would be good on the 2 cross 2. So here I'm solving the 2 cross 2. First you have to solve the bottom layer. That would take 3 minutes. But anyway, I'll show it to you on the GabaSoft simulator. So here if you see in the GabaSoft simulator, you can change the number of Rubik's Cubes. So I'm going down until I see the 2 cross 2. So this is the 2 cross 2 Rubik's Cube. That is in the solved position. So first you have to solve, I'll tell you the algorithms. You can see the videos and then you can do it here. So if you have a close-up for this. So first you have to solve the bottom 2 layers. You have to solve the bottom layer by algorithm, and then you have to use Ruri, Ururi, and then that is the algorithm I'll show you. So now it's a solved cube. So now let us see what happens if we do the algorithm. This is R, U, R, I, U, R, U, U, R, I. So if you do this, you get this kind of configuration. That is the algorithm which leads to this scramble. So that is the algorithm you need to do to solve once you are in this state. So once you are here, you solve it by this. I will show the algorithm at the bottom. So again we'll do the same algorithm. If you do the algorithm thrice, you get back the solved cube. So here we'll do the algorithm. R U R I U R U U R I. So that's the solved algorithm. Now the next algorithm is Rifri Bir Firi Bir. So for that algorithm, I'll show you the. This is Rifri Bir Firi Bir, and then UI. So basically, in this, you are left with two spaces, two corners. If these two corners are like that, then we will be able to get the algorithm. One second, I'll just see whether the video is coming well. Yeah, it seems to be coming well. So this should be full screen in the video. And see, let's do that again then. Here, basically, ref, re, vir, fi, re, bir. So that's there. There, we have solved the 2 cross 2. Now let us move on to 3 cross 3. So I'm going to take it to the solved state. In this solved state, first you solve the first layer. First you solve the cuboid here. So yellow is the top face. Yellow is the top face. And then white is the bottom face. Red is the right face. Red is front, and green is right of red. Now here first what you do is you solve a cuboid. Here you solve a cuboid like this with red, white and green. You solve a 2 cross 2. Then you solve a 3 cross 3. 2 cross 3. You solve it here to the orange face. You solve a cuboid 2 cross 3. And then we come to the point where there are some edges which might be flipped. So let me show you that algorithm here quickly. So you just do bottom, yeah. So basically what we have done is we have done that algorithm. Now what you see here is that the blue is not matching with blue here. And the yellow is not matching with yellow. So after you solve the 2 cross 3, you have to do this algorithm. So here you have done the 2 cross 3 cuboid, as you see, with red, green and white. So after doing that, first you have to match this to prevent. So in the online thing shown on the official website for 3 cross 3, they do it later, but here I do it earlier. So this is the key to it. It's easier that way. So if you do this, you keep the cube like this. You do bottom clockwise. Then you do R clockwise. And then again you do front. So this way you see that it has again resulted in some mistakes. Let me go undo the mistakes. So here we'll do it again. That's all. Only 3 steps. So here the blue and yellow are mismatched. So we put it here in the extreme positions. You put one here and then the other here. You put one here and the other here. And then you do bottom, front, right, and then bottom, anti-clockwise. So it's B. First time I am also seeing the algorithm so that you get a plus, nice plus here. And then you can get the blues here. So this is the step. I'm directly going to that step. It's hard to scramble it each time and take you there. So this is bottom, B. I'll write it down somewhere. I think basically I need to write it down. So here you can keep seeing the other Rubik's cubes until then. You can keep seeing the Rubik's cube 7 cross 7 and all those things. So I need to write it down. So it is, let's have a book here so that we can show some steps. We can write down some steps. So that's bottom, right, So let us see what we did here again. Let's do that again. So I did bottom B, then R, then B prime. B, R, B prime. It's only a 3-step move. So that I can do again. So now what happens, you can see that the yellow is scrambled and the blue is also scrambled. So you bring it to the positions. You bring it to the extreme positions. One here on the right, right, and then in the bottom, and then now you do this B, R, B prime, and then as you see it's fixed here. Now let us do the top layer. So now after that you can use your common sense to do these 2 layers, and then you can get the 2 layers. After you fix this edge, you can do the 2 layers at the bottom, and then you get a plus yellow at the top. So you solve the 2 layers with common sense. There are many steps which I'm going to skip because it's going to be an extremely long video. You solve the 2 layers with common sense, and then you can do the top layer. In the top layer you have a plus already, and then you use the 2x2 solving methods, that is Rifri and the Ruri, Ururi, and then Rifri, and then after that you do that to solve the 4 edges as though it's a 2x2 cube. I'm not going to show you these steps. So you solve the 4 edges, and then you do the final step for that is full Rifli rough. I have shown you in the text. I'll show it to you in the text. I'll try to add the text of it. So I showed it to you in the beginning of the video. So that is F, U, L, R, F, L, I, R, U, F. So as you see, this has brought the edges like this in a cyclic manner. I have permuted it. So basically at the back you need to keep it fixed, and then at the front you see the parts, and then you do the video. So here you have to do anti-clockwise UI. So you can choose between doing FFU full and FFUI. You can choose between doing it clockwise and anti-clockwise. That's an important thing to note. So now let me do it again to solve this Rubik's Cube from this position. So you solve the 2x3, and then you solve the side edge, then you did the 2 layers, and then the final step is here. So now I'll do this full FFUIL, FFUIL, Rif, R, U, I, F, F. So there, we have solved the 3x3. So now we have solved the 2x2 and 3x3. And then let us solve the next cube, that is the 4x4. So I'm going to take a small break here. We have solved the 2x2 and 3x3. We will skip over and solve the 5x5, because if you solve the 5x5, the algorithm to solve the edges, these are called triple edges or the double edges in the 4x4. So you solve the edge pairing. There's an edge pairing algorithm which I will show you now. So the edge pairing algorithm is the same for 4x4 and 5x5. There is another algorithm for 4x4, but you can forget that. If you want to remember only a set of things on top of your head, you can solve the 5x5. To solve the 5x5, now that we solved the 3x3, there are centers. You have to solve the centers in a particular way. So you can solve a triple bar, you can solve a triple bar, and then you can solve the next triple bar, and then you can solve the next triple bar, and then you can do the opposite side for the yellow. You can solve the triple bar with the common sense. Lot of videos take a long time in this, so when you see those, I'm not going to focus on those, solving the centers. So you solve the triple bar here, triple bar and triple bar. The only trick is in solving the final triple bar. So there is an algorithm. So to solve this final triple bar, so we want to, we want to get this yellow here without disturbing this here. So basically what you do is you do this, and then if you do that, you get back the yellow. So if you got that, I'm going to do that again. I'll do it on the simulator so that you can see what I did. So that algorithm you have to use to solve the final, the opposite centers. You have to solve white and yellow, and then you solve, say, green and red. You solve red and then you solve green. So when you're solving red and green, you can use the same. You can solve the triple bar for the yellow, for the red. And then you solve the triple bar here, another triple bar, see 3 triple bars. You have to use common sense, you have to use some rotations, and you have to use other layers to solve it without disturbing these two centers. And then you can solve the green too. I'm going a bit fast over this. There are a lot of videos, especially on the original website. I don't know his name, but I solved those videos. But he uses double pieces to solve it. But if you solve higher cubes, it's easier to solve it with triple bars for the centers. And then the final thing, you have to use 1, 2, 3, 2 prime, 1, 2, 1 prime, 2 prime, 2, 3 prime. 1, 2, 3 to 1, 2, 3. You can remember it like that. I'll show you the algorithm here to solve the final 2 centers. So let us move on to the 5x5 cube here on the simulator. So now this is the 5x5 simulator, 5x5 cube on the simulator. And then there's a parity, edge parity algorithm. So in the 5x5 cube, we can see that we are going to solve the centers first. So now I'm going to do something for the red and blue. Once you solve the first center, to solve the second center, you have to use a special algorithm in the final step always. Here and here in the red and green. So that we do always, we solve white, yellow, and then red and green. Because then for the 4x4, you need to remember that green is to the right of red and then blue is behind green. So now what we do is, let's see the blue, green and red. So I'm going to, so now when you want to solve this here, you can't directly just put it here. If you just put it here, then you can't get that red piece back here. So to solve this, what you have to do is you have to replace these two sides. So basically, because of the similarity, you do this once, you do R1 prime, and then R1 prime, R1, and then you do U2, and then you do R1 prime. So that way we are able to solve it. We have to do that, and the same algorithm you use for the these two edges. So basically I'm going to show you how to do this. So now when you want to solve this yellow, to put it there, but we imagine that the white is not disturbed. Usually the white is not disturbed. So to put it there, what you have to do is, this is not a sufficient thing, but what you have to do is you have to do this twice, and then do that twice, and then you have to do that. And then it gets solved. But typically the white is not disturbed, and then the yellow is disturbed. Yellow is not there. So that's how you do it. So this is just a demo for that. I'm not able to get that condition without solving it all the way from the first. So please adjust with that. See the other video for how this part is done. The center solving part is done. So now we move on to the edge pairing. Once you have solved the centers, you have to do the edge pairing. So to do the edge pairing, we do this algorithm. U1 prime, U1 prime, R, then U, then R prime, then U1, U1U. So that is the thing we did. So basically what happened, as you see, is these two edges are swapped. So now basically what I'm going to do is I'm going to fix this here. So to pair this edge with this triple edge, all that you have to do is you have to bring this there. So for that, I hope it's zoomed in, right? So for that, what we have to do is we have to do this algorithm. You can see it in detail for edge pairing. U1 prime. You have to do this for all, for 2 cross, from 4 cross 4 to 20 cross 20, you'll be using the same method. U1 prime, then R, then U, bring it here, and then you fix the other center again. Then R prime, then U1. So this goes here. So while doing this, I'm going to show you. So while doing this, you have to make sure that these three are not disturbed. So typically you have to make sure that when solving this here, you have to see that this piece is not solved. So for that you can move it here. So you can see that this piece is not solved. And then you can do this algorithm here so that those are not disturbed. This is the edge which gets disturbed. So when solving it, you have to make sure that this is not solved. So that algorithm is one thing. So then the next algorithm is the parity algorithm. So you do the edges, you do these two edges. First you do 2 edges, and then you do the third edge. And in doing the third edge, in the last edge, you'll be getting a parity. So you might be getting a parity. If you get a parity, all that you have to do is, I'll show you the algorithm as though you've got parity. You have to put these two on the top. You have to put the 2 edges which needs to be swapped on the top. And then you have to do this algorithm. L prime, U2, L prime, U2, then F2, L prime, F2, then RR, then U2, RR prime, then LL2. So basically, when you do this algorithm, the edges should be swapped, but it was not the case. Let's do it again. I might have made a mistake. So this is quite critical. LL prime, U2, LL prime, U2, then F2, LL prime, F2, then RR, then U2, RR prime, U2, then LL2. So as you see, these 2 edges are swapped here along with the corners, but we are solving the edges, so we don't have to worry about the corners. So these 2 edges are swapped. So to unswap these 2, so basically what you see is you have to see that this goes there and that goes here. So to swap this, you have to use this algorithm, this parity algorithm, which I show below. So let's do that here again. So now we have to do this. LL prime, U2, LL prime, U2, then F2, LL prime, F2, then RR, then U2, RR prime, then U2, LL2. So now I think I made a mistake. I put that in the front, I think. So now 2 more edges are swapped. So now we can solve it like a normal cube, but anyway you have to use this parity algorithm. You will be able to solve it. I was unable to show it successfully here, but if you use the algorithm blindly by keeping it at the top, then you will be able to swap it. For example, let's try to swap these two here. Let's see if that works. So you have to put it like this. I didn't start. So if you see back, so if you see I put it in the front. So now we have to solve the parity of these 2. So these two, this has to go there and that has to go here. So now we keep it like this. LL prime U2, LL prime U2, then F2, LL prime F2, then RR, then U2, RR prime U2, then LL2. Yeah, this time I was able to do it successfully. So now we have solved the 5 cross 5, but actually we hadn't solved the centers and corners. So after solving this part, after solving the parity for the triple edges, basically you solve two of the edges of the triple edges at a time. Then you solve the third edge by keeping the unsolved thing here when doing the algorithm. So now basically you solve the triple edges, and then after that you solve it like a 3 cross 3. I'm not going to go over that here. So you solved a 5 cross 5. So let us clap for the moment. And now let us look at the 4 cross 4. Or actually I'm going to look at the 6 cross 6. In the 4 cross 4, once you solve this double edges with the same edge pairing mechanism, you might get some parities. So to fix the parity, you have an algorithm. Let's go all the way to the 8 cross 8 actually. Let's go up. This is 1, 2, 3, 4, 5, 6, 7, 7 cross 7. And this is the 8 cross 8. 3. So once in the 4 cross 4 or the 8 cross 8 or any even numbered cube, what you get is you're able to solve the edges like the 5 cross 5. And once you solve the edges, so this algorithm which I showed you for the 5 cross 5 can be used for 7 cross 7 and all those things. In the 7 cross 7, I'm going to quickly show it to you here. You solve this edge and then you solve this edge, and when you solve this edge and this edge, you solve the inner 3 layers. So there are 5 edges in that is penta edge basically. Pedge, I call it a pedge. So in a 7 cross 7 there is a pedge. So you solve the triple edge like the 5 cross 5 with the same parity algorithm, and then you solve the outer pent edge for the 7 cross 7. So with the same edge pairing algorithm, and then you solve it like a 3 cross 3. For solving the 7 cross 7 and higher cubes, 9 cross 9 and all that, you do the same thing. You solve the center. So let me show it to you on the, no, you can see it here. So you solve the center, and then maybe you can zoom in if required here. So you solve the center first for the 7 cross 7. Let us first go over how to solve the 7 odd numbered cubes, and then we will look at the 4 cross 4. So we solve the edge centers first. So first you solve bars like this, 5 cross 1 bars, and then you solve these bars, and then you solve the next layers, and you use the same method that you used with the U2 and then R1, R2, R3 and so on. So R1, 2, then R1 or something. So basically you solve the center pieces on the other layers and then you shift it up. So that's how you solve the centers for the 7 cross 7. Maybe we can then use the red and then green, same method, and then you use the 1, 2, 3 to 1, 2, 3 with the correct primes. So here you have to remember that while doing it, there will be a choice between doing F and F prime. So when you are solving this piece and this piece, you will do an F. If you do an F, it will be in the same layer and then you can't move it across. So the idea of the 1, 2, 3 to 1, 2, 3 is that you bring that piece front here. You bring that piece front here. So I'm going to be showing you how to swap this piece with this piece. So you do R1 prime, then you have to do an F prime. You have to do an F prime, R1 prime, F prime, and then L1, and then you do F, R1, then F prime, that is F prime, and then you do L1 prime. So when you do this 1, 2, 3 to 1, 2, 3 with if you, that's easy to remember, but then it's 1 2 3, then 2 prime, then 1 prime, then 2 3 prime. When you do that, it gets swapped. So you can see that these two pieces from here got swapped, and you fix it with the correct full swapping. You see that these two pieces got swapped. So in a similar way, you go on and then fix all the swaps. You have to choose between F and F prime to take the piece out of the way to the bottom layer to save it. So that way we are able to solve the second and the third, the last two centers, the fifth and the sixth centers. So once you solve the 6 centers, then I can do the algorithm again for your convenience. So I'm going to be swapping this with this. So I'm going to do R1 prime, F prime. If I do F, it will be in the same thing and I can't move it again. So basically you have to do R1 prime, then F prime, then L1, then F, then R1 prime, R1, then L1 prime. Then it got solved. So you can see that these two centers got solved. So that is the algorithm. You can do it for M and all those layers. You have to use M. You have to use M prime. So you have to use all that. It's a complex thing, and then you have to solve it. It's not very clearly given elsewhere. I've seen all the way in the web. This is the easiest way to solve the centers. So after solving the centers, as I outlined, you solve the triple edge, like the 5x5, and you have to skip the last but one layer, the first and the fifth layer you have to skip, and then you have to use the algorithm. It's kind of complex. You have to do something like this. You have to do something like this sometimes, and then but it's worth it. So you have to skip the third layer when doing the UU prime algorithm, or the BB prime, or you have to use BB prime sometimes to get this algorithm. You can use the other side also, the other way you have to flip it, but you have to remember to do if you do BB instead of BB prime, you have to do BB. I'm not going to go around showing all those because it's available in the videos, and you can put 2 plus 2 together to get this idea, because this is a short video. So that's how you solve the 7x7, folks. It's going to take 4 hours, but it's worth it. So after solving the 7x7, now let us look at the even layered cubes. Let us pause this video here. Okay, now that we have done the 7x7 and now we know how to do the 9x9 and other cubes, let us look at the 8x8. So now we have to look at the 8x8. And now I'm going to show you the edge parity pairing algorithm. After you solve the 3x3 Rubik's Cube, after you solve the edges here, I showed you an algorithm to do this here. And basically what we can do is, when doing that, one of the edges may be flipped, and then you have to use this algorithm. But we'll show it to you at the same time as doing it for bigger cubes. Whenever you have a small r, you have to use this 2r, 2b, 2u and L, 2u, ri, 2u, r, 2u, 2f, r, 2f, li, 2b, 2r. So when you have the small r, you do all the inner layers, and when you have the small l, you do all the inner layers. So for the 8x8, let us do this algorithm here quickly. So I'm going to be flipping this edge. Basically, I'm going to choose an yellow edge, and then I'm going to be flipping this edge. I'm going to be flipping this edge. So for that, let us do this algorithm. Okay, let us do this algorithm. There are 6 inner edges for the 8x8. So let us do this algorithm. 2r, basically 2r, 2r, then 2b, 2 small r, 2b, then 2u, then L, then 2u, then R inverse, then 2u, then R, then 2u, then 2F, then R, then 2F, then L inverse, then 2B. Okay, 2B is that way. Then 2B, then 2R. So as you see, I've flipped this one particular edge here. So when solving the 4x4 or other cubes, you'll have this edge parity 1. This is case 1, where the flipped edge is there. Then you have to follow this algorithm and then you can unflip it. So then I'm going to show you how to do the other edge parity. So there are only 3 cases of edge parity for the even faced cubes, all the way up to 20 by 20. So here this is the other edge parity, where these two are flipped. These two are flipped. Green and orange are flipped after solving the edge. Now that first edge parity came before solving the corners. After solving the corners, this last edge parity will come. So there are 2 cases. I'll show you both. So here you do 2R, down inverse, down inverse, then 2R, then 2R, and 2U, and 2F, then 2R, and 2F, then 2U, then 2R, then 2R, then down, then 2R. So as you see, these two got flipped, and you can use the same algorithm again to fix that kind of. So for the 8x8, what you do is first you solve the centers like you do for the other layers, for the other cubes. Then you solve the edges using the edge pairing algorithm with the parity operator and all those things. And then you have these, the final layer, you have this problem. So for that you use the 4x4 thing. I have given the thing in the bottom. So the other thing, last case, and then we have done solving even the 20x20, is when the 2 edges are opposite to each other. So the orange and the red. So basically we're going to do it 2R, 2R, 2U, then 2R, then 2U, and 2U, small u, and 2R, and 2U. So as you see, these 2 edges are swapped, and that is the final case, folks. And now with this video lecture, you'll be able to solve any cube from 2x2 to 20x20, or that's the available thing on GabaSoft. If you want to solve bigger cubes, it's available on Amazon, I think, or some special place. So you can solve any cube, any size with this video lecture. Hope it helped. Put your comments below, like and share this video. So please like and share this video and subscribe to my channel. Thank you.